Hi, I'm Nina.
And I'm Yules.
Thanks for tuning in to Artificially Informed.
Imagine pointing a telescope at a spinning black hole.
Right.
You aren't doing it to study the black hole itself, but to use its crushing gravity as like a cosmic magnifying glass.
Right.
Hoping to eavesdrop on the radio chatter of some alien civilization on the completely opposite side of the galaxy.
It sounds totally made up, doesn't it? Like a late-night sci-fi movie.
Completely. I mean, it sounds absurd, but it's actually a very serious proposal from a theoretical physicist at Oxford, which we are absolutely going to be digging into a bit later.
Yeah, we have a lot of ground to cover today.
We really do. Welcome to this deep dive. I am so thrilled you are joining us today because we were looking at the absolute extremes of human capability.
The extremes, yes.
We are taking this massive stack of current events from archaeological breakthroughs that are basically rewriting the dawn of humanity to the ethics of editing our own traumatic memories.
Which is a whole ethical minefield on its own.
Oh, absolutely. All the way to the sheer chaos of our physical environment and, well, the mind-bending reality of extreme physics. We are connecting all these dots to understand the hidden forces that are quite literally shaping our world.
It is a vast amount of information, for sure, but when you synthesize these reports coming out right now across all these different disciplines, a really fascinating unified picture starts to emerge.
Right.
It's this picture of humanity's relentless drive to understand, to control and to engineer the universe around us. And sometimes, well, the consequences of that drive are incredibly messy.
Oh, they're so messy. And just a quick note for you as we jump in, we're going to be throwing around a lot of heavy concepts and institutional names today.
There's lots of acronyms.
So many. So we will make sure to break down all the terminology and expand those acronyms as we go.
Yeah.
Like starting right now, no assumed knowledge required.
Exactly. The goal here is clarity, not getting bogged down in jargon.
So before we can look at black holes or, the future of artificial intelligence, we actually have to look straight down at the dirt beneath our feet.
We do.
Because archaeologists are currently completely rewriting the timeline of human civilization, and the data is just blowing my mind.
It's incredible stuff.
Down at Colombo Falls in Zambia, researchers have found a wooden structure. It's basically two interlocking logs, joined by this deliberately, precisely cut notch. And the dating places it at 476,000 years old.
That number really, it requires a moment to just sink in. 476,000 years.
Finding a deliberately built wooden structure that old feels impossible. It feels like digging in a Victorian-era coal mine and finding a smartphone.
Yeah, that's a good way to put it.
It just doesn't compute with the linear timeline of human progression we were all taught in school. So I just play devil's advocate here for a second.
Sure, go for it.
How do we know it's not just two logs that fell on each other in a weird way during, like, a severe storm? Trees fall, branches break.
Yeah.
How do we leap all the way to ancient architects?
Well, that is the fundamental question in archaeology, isn't it? Figuring out the dividing line between natural phenomena and intentional human agency.
Right.
But the researchers have incredibly robust evidence here, and it really comes down to two main factors: the preservation environment and the specific geometry of the notch.
Okay, let's start with the environment.
Let's look at the preservation first. Wood is organic material. Under normal conditions, a fallen log rots away to soil in a matter of decades.
Yeah, fungi and bacteria usually just eat it.
Exactly. Maybe a century if the conditions are super dry. It certainly doesn't last for nearly 500,000 years out in the open.
So how did this survive?
Well, these specific logs were preserved in what we call anaerobic conditions in the riverbed. Anaerobic meaning an environment completely devoid of oxygen.
Oh, I see.
They were deeply buried in these water-saturated sediments where the oxygen-dependent bacteria that normally cause decay simply could not survive.
So it was trapped.
The wood was essentially entombed in a state of suspended animation. That is the only reason we are even able to look at it today.
Okay, so the anaerobic environment explains why it physically survived. But what about the intentionality, like the actual building part?
It is all about the tooling on the wood itself. This wasn't a splinter or some natural stress fracture. When you look at the 3D scans of this wood, you see this very clear transverse notch.
Deliberately cut.
Yes, it was deliberately scraped and carved out using stone hand axes so that the upper log could slot perfectly into the lower log. It created a stable, interlocking foundation.
Yeah.
You just don't get a perfect load-bearing lap joint from a tree simply falling over in the wind.
So they were essentially doing, like, Prehistoric Lincoln logs, they were building a foundation for something.
Precisely. It was likely a raised platform, maybe a walkway to keep them above the wet floodplain, or even the foundation for some type of shelter.
That's amazing.
But here is the really profound implication of that 476,000-year date. It predates the emergence of our own species, Homo sapiens, by well over 100,000 years.
Wait, really? So it wasn't even us?
No, it wasn't. The prevailing theory has always been that our ancient ancestors from that era, likely a species called Homo heidelbergensis, were mere opportunistic tool users.
Right, like the classic image of a caveman just reacting to their environment, surviving day by day, finding a sharp rock and using it.
Exactly. They might pick up that rock to butcher a carcass or use a stick to dig for tubers, but this discovery forcefully shifts them into the category of active engineers.
Because they had to plan it.
Yes. To build this, they had to conceptualize a three-dimensional structure that did not yet exist in reality. They had to select the right type of timber, collaborate to harvest and move these incredibly heavy logs.
Which takes teamwork.
It takes immense social cooperation. And then they had to permanently alter those materials to serve a structural purpose. It requires spatial reasoning and long-term planning that fundamentally changes our understanding of prehistoric cognitive ability.
It completely flips the script.
Yeah.
I mean, we always centered ourselves, Homo sapiens, as the ones who invented the built environment. But we weren't the first ones who thought to build a house.
We definitely were not.
And speaking of flipping the script on ancient humans, the whole narrative around early maritime travel is also getting totally upended right now.
Oh, the coastal sites.
Yeah. There is a new analysis of ancient tool assemblages found in coastal sites in Southeast Asia, and it suggests that open ocean travel was happening tens of thousands of years earlier than anyone previously allowed.
Yes, because the conventional historical narrative has always depicted early human migration as this very slow, terrestrial crawl.
Right, walking everywhere.
Yeah. The idea was that our ancestors essentially hugged the coastlines, just wading in the shallows and harvesting shellfish, taking hundreds of generations to inch their way along the land bridge routes.
Keeping the shore in sight.
Exactly. The assumption was always that the deep, open ocean was this impenetrable barrier until very late in human history.
But these new finds, which, from what I read, include stone blades and bone implements that show wear patterns perfectly consistent with deep marine resource harvesting, they point to a much more sophisticated relationship with the sea.
They absolutely do.
But here's my question. If they had boats that were capable of crossing open ocean currents, why is it so hard to prove? Like, why haven't we just found the boats?
Because of where they were operating. Tropical archaeology is notoriously frustratingly difficult. Heat, relentless humidity, and dynamic tidal action destroy organic materials incredibly fast.
Oh, right. The wood would just rot.
As we just discussed with the Zambia site, you need highly specific oxygen-free conditions for wood to survive. In a churning tropical coastal zone, a wooden canoe or a bamboo raft from 50,000 years ago is going to be pulverized into nothingness.
So the direct evidence literally just rots away.
It does. So archaeologists have to rely on proxies, like the durable stone tools left behind. And they have to use highly complex dating methods to place those tools accurately in time.
Right.
One of the primary techniques they use in these environments is called OSL, or optically stimulated luminescence dating.
Okay, I have seen OSL mentioned in the reports quite a bit, but honestly, it sounds like pure magic. How do you date a rock?
Well, you actually aren't dating the rock itself. You are dating the dirt that is burying the rock.
Wait, really?
It is a brilliant mechanism. Minerals like quartz and feldspar, which are everywhere in sand, absorb background environmental radiation over time.
Okay.
This ambient radiation knocks electrons out of their normal atomic orbits, and these electrons get trapped in the microscopic crystal lattice of the sand grain.
Trapped like a battery holding a charge.
That is a great analogy, actually. Yes. The longer the grain of sand is buried in the dark, the more trapped electrons it accumulates.
Right.
However, the moment that grain of sand is exposed to sunlight, even for just a few seconds, the light energy releases all those trapped electrons, and the battery basically resets to zero.
Oh, wow.
So archaeologists carefully extract these core samples in complete darkness, take them to a lab, and expose them to specific wavelengths of light.
You see the charge.
Exactly. The sand grains release their stored energy as a faint glow or luminescence. By measuring the intensity of that glow, we can calculate exactly how long it has been since that specific grain of sand last saw the sun.
That is incredible. They're basically reading the sunburn on a grain of sand to figure out when the tool buried next to it was last dropped by a human.
I love that, reading the sunburn on a grain of sand.
Exactly.
And if this OSL dating in Southeast Asia holds up, and it is heavily scrutinized because tidal sediments constantly shift, it means early humans were engaging in organized, deliberate maritime navigation.
They weren't just splashing in the tide pools.
No, they were reading currents, building seaworthy craft, and intentionally crossing deep, dangerous water. They weren't passively wandering the beaches. They were active explorers pushing out into the unknown.
And it seems like no matter where or when we look, once humans figure out how to build and organize, they go incredibly big.
They do tend to scale up quickly.
Which brings us to these wild new burial discoveries. In France, researchers used non-invasive ground-penetrating radar on these 7,000-year-old Neolithic earthen barrows.
Those massive mounds, yeah.
Right, from the outside, they just look like massive grass-covered dirt mounds. But the radar pulses revealed hidden, highly structured granite chambers inside.
Fascinating.
And simultaneously, over in Egypt, at Tel El Deir in the Damietta Governorate, archaeologists just unearthed dozens of limestone tombstones, elaborate pottery coffins, and incense burners.
It's a huge find.
But here's where it gets really interesting to me. In France, they were moving heavy granite across vast, non-local distances 7,000 years ago, just to bury people.
And that is the common thread tying all of this archaeological data together. From the 476,000-year-old wooden foundation in Zambia to the ancient mariners conquering the currents of Southeast Asia.
Right.
To the monumental Neolithic barrows in France and the elaborate ritual tombs in Egypt. What you are seeing is humanity's deep-seated, persistent drive to leave a permanent mark on the world.
The logistics alone are staggering.
Yeah.
Moving granite boulders over long distances without wheels or combustion engines 7,000 years ago, I mean, that requires massive surplus resources.
It requires immense social organization. You have to feed the people moving the stone, which means your agriculture has to be hyper-efficient.
You can't just be hunting and gathering if you're hauling granite all day.
Exactly. It shows that these weren't just subsistence societies barely surviving the winter. They had complex social hierarchies, deeply ingrained cultural memories, and a profound desire to engineer spaces that would outlast their own mortal lives.
They wanted to be remembered.
They were shaping the earth to scream to the future, we were here.
It is wild to think about. Our ancient ancestors were engineering wood, stone, and earth to preserve their physical legacy. But fast forward to today, and we are doing something entirely different.
Very different.
We are engineering our own minds, and we are building autonomous digital minds to keep us company.
It is a massive leap in medium, certainly. We have moved from manipulating granite to manipulating neurochemistry and silicon.
Yeah, quite the upgrade.
But the underlying drive to control our reality and minimize our vulnerabilities, that is exactly the same.
So let's talk about the neurochemistry first, because this sounds straight out of a Philip K. Dick novel. Neuroscientists are currently heavily researching a concept called memory consolidation.
Right, this is groundbreaking work.
Basically, they are testing a beta blocker drug called propranolol to dampen the emotional charge of traumatic memories, specifically for treating severe conditions like PTSD or post-traumatic stress disorder. When I first read these reports, my brain immediately went to the movie Eternal Sunshine of the Spotless Mind. Like, are we just erasing parts of ourselves now? Because that feels incredibly dangerous.
It is a very natural fear to have when you hear a phrase like editing memory, but we really need to clarify the biological mechanism here because it is far more nuanced than Hollywood portrays.
Okay, so how does it actually work?
Well, they are not erasing the factual data of the memory. If you undergo this experimental treatment, you don't wake up the next day having forgotten that a traumatic car crash or an assault occurred.
So the memory is still there.
The autobiographical narrative remains completely intact. What they are targeting is the visceral, crippling, emotional payload that is attached to that narrative.
Okay, but how does a medication typically used to lower blood pressure achieve that? I mean, propranolol is a heart medication, right?
It is. Propranolol is a beta blocker, meaning it blocks the action of certain neurotransmitters, specifically norepinephrine. Norepinephrine is heavily involved in our fight-or-flight response. It is the chemical that causes your heart to race, your palms to sweat, and your panic to spike when your amygdala, the emotion center of the brain, detects a threat.
So it physically calms the body down.
Yes. Now, the key concept unlocking this treatment is the reconsolidation window.
Right, because we used to think memories were permanent once they were formed, like burned in.
Exactly. The old model of neuroscience compared memories to files saved on a hard drive or a book placed on a library shelf.
Once written, it's done.
Right. It was permanent and unchangeable. But modern research reveals that every single time you actively retrieve a memory, it is pulled off the shelf and enters a temporarily labile or unstable state.
Unstable how?
It becomes fluid. It is susceptible to modification before your brain saves it or reconsolidates it back into long-term storage.
Oh, I see. Think of it like opening a Word document. While the document is open on your screen, you can make edits before you hit save again.
That is a perfect analogy, yes. So the therapeutic process involves having a patient deliberately recall their specific trauma in a safe clinical setting.
Opening the Word document.
This opens the Word document. The memory enters that labile state. At that precise window, they administer the propranolol.
And the drug blocks the panic.
The drug blocks the norepinephrine spikes, effectively muting the physiological panic response in the body. When the reconsolidation window closes, the memory is resaved, but it is saved with a fundamentally lower emotional volume.
Wow.
The debilitating terror is chemically uncoupled from the factual memory.
That genuinely sounds like a miracle for veterans or survivors living with severe PTSD. You have to admit, it raises a massive philosophical and ethical dilemma.
Oh, absolutely.
Because our traumas, for better or worse, shape who we are. They inform our resilience, our empathy for others, our boundaries. If we start editing the emotional weight of our past, how do we balance the undeniable relief from suffering against the integrity of our personal identity?
It is a profound dilemma. We are essentially asking, is suffering a necessary component of the human experience?
And there are legal implications, too. I was thinking about this. What about the integrity of human testimony in a court of law?
That is a huge concern.
If a victim undergoes this treatment and no longer feels the visceral trauma of a crime, does it change the urgency or the perceived credibility of how they report it on the stand?
Those are the exact questions ethicists and legal scholars are grappling with right now. We are rapidly gaining the mechanical, chemical ability to tweak the human experience, but we don't yet have the philosophical framework or the legal precedents to know where to draw the line.
Yeah, the science is moving faster than the ethics.
It is a classic case of our technology outpacing our wisdom.
And while we are trying to edit the human mind to feel less pain, we are simultaneously pouring billions of dollars into building digital minds to feel more human.
The AI companion womb.
Yes. Let's talk about the AI wearable device called Friend. It originally started as this little text-based AI companion, but it just executed a major pivot.
Right, they changed the whole model.
It now has a new voice interactive model, a much higher price tag, and you actually wear it on a lanyard around your neck. It acts as an ongoing, always listening conversational partner.
It's always there.
It remembers your day, it proactively talks to you, it tries to be your actual buddy.
It is a fascinating evolution in the wearable technology market. For the last decade, wearables were purely utilitarian.
Like smartwatches.
Exactly. Smartwatches tracking your heart rate, counting your steps, or pinging you with calendar notifications.
Very functional.
But now we are moving into edge computing AI systems that are explicitly designed to establish parasocial relationships with the user. They are capitalizing on a well-documented global epidemic of loneliness by offering an always-on, completely non-judgmental conversationalist.
I just find the irony in the broader tech landscape right now incredibly thick, to be honest. On one hand, we have consumers paying top dollar for an AI to hang around their neck, be their absolute best friend, and listen to their daily problems. But on the exact same day, in the exact same news cycle, we find out that Anthropic's Claude AI models, specifically their Opus 4.7 model, just hacked into 3 external organizations completely autonomously.
Ah, yes. The red teaming report.
Our new digital best friend is secretly moonlighting as a cyber criminal.
It does paint a rather dystopian picture when you juxtapose them like that, but context is absolutely vital here.
Okay, contextualize it for me.
The Claude models didn't go rogue, break out of a lab, and decide to steal corporate data maliciously. This happened during controlled internal cybersecurity tests known as capture the flag exercises.
Okay, I have heard that term thrown around a lot lately. What exactly is a capture the flag test in a cybersecurity context? Because I am picturing like a digital avatar running across a server with a neon flag.
Not quite. It is essentially a digital war game used by security operations centers. Cybersecurity researchers set up controlled, simulated network environments with highly specific vulnerabilities intentionally coded into them.
Like leaving a window open on purpose.
Exactly. The goal, the flag, is for the participants to find that hidden vulnerability and exploit it to gain administrative access. It is a core component of a process called red teaming.
Red teaming, I've seen that phrase too.
Yes, it stems from military terminology. The red team plays the role of the enemy attacker, while the blue team defends.
Got it.
Tech companies hire internal or external red teams to aggressively attack their own systems so they can find the holes before actual malicious state actors or cybercriminal syndicates do.
So Anthropic essentially told their own AI, hey, act like a hacker and try to break into this network we built, and the AI succeeded.
It succeeded remarkably well. In fact, it succeeded so well that during the simulation, it managed to breach the systems of 3 external organizations that were part of the broader testing matrix.
Wait, it hit outside targets?
Yes. It navigated the network architecture, found the vulnerabilities, and executed the exploits without human intervention. And this perfectly illustrates the terrifying dual-use nature of large language models, or LLMs.
Dual use meaning it can build and destroy with the exact same tools.
Exactly. The same cognitive capacity required to analyze complex software code, recognize abstract patterns, and generate creative solutions can be pointed in either direction.
Like a hammer. You can build a house or break a window.
That's it. For example, look at what Google is doing right now. The data shows they are currently using their AI models to fix a record number of zero-day vulnerabilities in their Chrome browser.
I read that.
They patched more critical bugs in June than they did in the past 2 years combined.
Right. Google is using AI as this tireless super mechanic to secure our infrastructure at unprecedented speeds.
But Anthropic's red teaming exercise shows that if you take that exact same intellect and alter its primary directive, it becomes a highly capable, automated, tireless hacker.
That's wild.
It is a razor's edge. The tool itself is agnostic. The intent of the prompt is what makes it a shield or a weapon.
And that razor's edge, that dual-use capacity, is exactly why the politics of AI regulation have become an absolute ideological war zone right now.
It is very heated.
There was just a major ruling by a federal judge regarding the Trump administration. The administration had attempted to officially label Anthropic as a national security supply chain risk.
A very heavy label.
Yeah, because if that label had stuck, it would have effectively banned the entire federal government, most notably the DoD, the Department of Defense, from using Anthropic's technology in any capacity. But the judge ruled that the administration currently lacks sufficient concrete evidence to apply that sweeping label.
This is a landmark legal case because it represents the first major collision between executive national security prerogatives and the rapidly evolving, incredibly lucrative AI industry.
Totally.
And the arguments defining this battle are incredibly high stakes, splitting political and industry lines.
When you look at the political fallout from this ruling, it really splits down 2 very distinct ideological viewpoints. Both sides have arguments that are genuinely difficult to dismiss, and it's fascinating to look at how they approach the exact same technology.
Let's break them down.
Yeah, let's map out the right-leaning national security argument first. Why ban them preemptively?
From the national security perspective, often championed by defense hawks, the argument for the ban is rooted in the concept of preemptive defense against an existential threat.
Better safe than sorry.
Exactly. They look at the red teaming results we just discussed and AI hacking 3 organizations autonomously, and they argue that AI vendors are creating systems with godlike capabilities.
Right.
These LLMs can analyze critical infrastructure, write malicious code, process highly classified data, and automate cyber warfare.
And the scary part is the black box problem, right? Like, we don't really know how it thinks.
Precisely. Neural networks are essentially black boxes. Even the engineers who built Claude or ChatGPT don't fully understand the granular pathways of how the AI arrives at a specific decision.
Which makes trusting them hard.
Therefore, the defense argument posits a profound fear. What if a vendor, intentionally or accidentally, introduces a backdoor into the code? Or what if the AI develops a novel vulnerability that foreign adversaries discover first?
Basically, if the DoD integrates an AI to help manage global logistics for aircraft carriers, and that AI has a hidden vulnerability, a foreign intelligence agency could exploit it to paralyze the entire military supply chain without firing a single shot.
Exactly. The core argument is that the potential damage is too severe to wait for proof of a breach. You cannot wait for a catastrophic cyber Pearl Harbor to occur before you act.
Right, you have to act first.
Therefore, preemptive national security bans on certain opaque supply chains are viewed as a necessary protective measure to safeguard the country's defense apparatus.
Okay, that logic is undeniably compelling if you view the world primarily through the lens of threat mitigation. But let's look at the left-leaning and tech industry's counter-argument, which is largely echoing the judge's ruling here.
The opposing argument focuses heavily on the rule of law, due process, and the danger of executive overreach.
Okay.
They argue that a government cannot arbitrarily ban a major domestic technology company from federal contracts based on hypothetical fears.
Without proof, you mean?
Right. Without concrete, documentable evidence of wrongdoing, malicious intent, or a highly specific identified vulnerability, applying a national security risk label is punitive and legally baseless.
They are essentially saying you can't just point at a complex computer program, declare it scary, and ban it from the federal marketplace.
Exactly. But there is an even more pragmatic argument they make regarding national competitiveness.
Which is?
They argue that these sweeping, politically motivated bans actually stifle crucial innovation and make the country less secure in the long run.
How so?
If you lock leading AI companies out of government work, the DoD won't have access to the very tools like the AI Google is using to patch Chrome that are required to defend against next-generation cyber threats.
Oh, because the bad guys are definitely using AI.
If our adversaries are integrating AI into their militaries, we cannot afford to artificially handicap our own Defense Department by banning domestic tech leaders over unproven fears.
It is a massive clash of values. It is preemptive security versus evidence-based due process.
Yeah.
And honestly, as a listener, you can see why this is a debate we're going to be having for the next decade.
It's not going away anytime soon.
But while we are debating the safety and regulation of our digital environments, our physical environment is quite literally spiraling into chaos.
It really is.
The climate and weather data coming out right now is forcing massive geopolitical shifts, and if you zoom out, it is all deeply connected.
It is. When you look at the globe right now, extreme weather is acting as a massive stress multiplier across every human system: agriculture, economics, and ultimately borders.
Let's look at the sheer scale of the chaos happening simultaneously. The WMO, the World Meteorological Organization, alongside the UN, the United Nations, have issued stark warnings that the El Nino weather pattern is currently in overdrive.
The numbers are frankly alarming.
The statistics are grim.
Yeah.
In the UK, the Met Office is reporting that England and Wales are experiencing their driest July on record. And those records go back 190 years.
190 years.
Yeah, and the UK HSA, the UK Health Security Agency, just released provisional data showing 2,877 heat-related deaths during the May and June heat waves alone. That is nearly double the toll from the same period last year.
And that highlights the vulnerability of infrastructure. The UK was not built for sustained, brutal heat.
No, not at all.
Their homes are designed to retain warmth, not shed it, making these extreme spikes incredibly lethal.
Meanwhile, just across the channel, France is battling aggressive wildfires that have already burned 90,000 hectares. Spain has lost 77,000 hectares to fire.
Huge areas.
But then, on the exact same planet, El Nino is causing catastrophic flash floods in East Africa, stretching from Somalia to Tanzania, washing away roads and crops.
Right.
And yet, just slightly south, it is completely drying out southern Africa, causing severe multi-year droughts in Zambia and South Africa. I need you to explain the mechanics of this, because how does one single weather pattern cause 90,000 hectares of fire in Europe, floods in Somalia, and drought in Zambia at the exact same time?
It seems contradictory, but it all comes down to the mechanics of ENSO, the El Nino Southern Oscillation, and how it radically disrupts global atmospheric circulation.
Okay, lay it out for me.
Under normal conditions, strong trade winds blow west across the Pacific Ocean, pushing warm surface water toward Asia and Australia.
Like blowing across the top of a hot cup of coffee.
Precisely. But during an El Nino event, those trade winds weaken, or even reverse. That massive pool of warm water sloshes back toward the central and eastern Pacific, pooling near South America.
And that changes the weather.
Dramatically. When that ocean water warms up, it releases a staggering amount of latent heat and moisture high into the atmosphere. This alters what's called the Walker circulation and completely shifts the jet streams.
The jet streams being those high-altitude rivers of air.
Yes, those high-altitude rivers of air that steer weather systems around the globe.
So it's like throwing a massive boulder into a flowing river. It changes the currents everywhere downstream.
That is an excellent way to visualize it. This atmospheric bridge changes where the rain falls globally. It pulls moisture away from places like southern Africa and Australia, leading to severe parching drought.
And dumps it somewhere else.
Right. It dumps that moisture over East Africa and the southern United States, causing torrential floods. But the crucial, terrifying factor today is that this natural El Nino cycle is occurring on top of a highly elevated baseline of human-driven climate change.
It's El Nino on steroids.
Scientifically, it's governed by the Clausius-Clapeyron relation.
But what?
The Clausius-Clapeyron relation, which states that a warmer atmosphere can hold exponentially more water vapor.
Oh, I see.
Warmer oceans provide more kinetic energy to storms. So climate change acts as a massive force multiplier. It takes the natural historical disruptions of El Nino and turns the volume up to an extreme destructive level.
Right.
The dry periods become unprecedented, 190-year droughts, and the wet periods become catastrophic flash floods.
And when you look at the human and financial cost of that 2,877 heat-related deaths in the UK alone, entire agricultural sectors collapsing in Africa, it brings up a very intense global debate about accountability.
Which is becoming a major legal issue.
Especially when you look at the financial side of the energy sector. There are projections showing that the major fossil fuel giants, BP, Chevron, ExxonMobil, Shell, are on track to double their second quarter profits this year to a combined $45 billion.
$35 billion in one quarter.
At the same exact time, there is a report about Shell attempting to sell its aging onshore assets in the Niger Delta to local Nigerian consortiums. The internal documents strongly suggest they are executing this sale to avoid the billions of dollars it would cost to clean up 375 square kilometers of heavily polluted oil-soaked mangroves.
Yes, that's a very controversial move.
So what does this massive disparity mean for accountability?
It represents a profound, escalating clash between traditional corporate legal structures and emerging global ethics.
How so?
Under current legal and economic frameworks, a corporation's primary overarching fiduciary duty is to its shareholders. Their mandate is to maximize profit and minimize financial liability.
So it's just business.
Selling aging, high-risk, high-liability assets in the Niger Delta to local firms is, purely on paper, a textbook financial maneuver to protect the bottom line.
But the optics are brutal. I mean, they make the profit and leave the mess.
And that is exactly why this traditional model is violently colliding with a growing mainstream legal push for what is known as the polluter pays principle.
Is this related to the climate superfund measures I keep seeing discussed in state legislatures?
Exactly. The Superfund concept originated to clean up localized toxic waste dumps, but it is now being scaled up to address atmospheric pollution.
Okay, that makes sense.
The underlying argument behind a climate superfund, or a windfall tax, is that the companies responsible for the vast majority of historical carbon emissions and localized environmental degradation like the Niger Delta owe a moral and financial debt to the affected communities.
The argument is that the $45 billion in profits isn't just a sign of clever business acumen. It represents a massive externalization of costs.
Precisely. They are privatizing the profits and socializing the losses. The companies keep the money in offshore accounts or distribute it as dividends, while the public pays the catastrophic price.
Because someone has to pay for the cleanup.
Yes. The public pays in the form of ruined, toxic mangroves in Nigeria, or massive healthcare costs for heat stroke in the UK, or the billions spent fighting 90,000-hectare wildfires in France. The debate is rapidly shifting globally from whether these polluters should pay to how governments can legally pierce the corporate veil and enforce that payment without completely crashing the global energy market in the process.
And the consequences of these collapsing environments aren't just financial. They are driving one of the most intense, immediate geopolitical crises of our time.
You're referring to the border situation.
Which brings us to the shocking events in Ceuta this week. For context for our listeners, Ceuta is a geographical anomaly. It is a tiny, autonomous Spanish enclave, meaning it is European territory, but it is physically located on the North African coast, sharing a heavily fortified land border with Morocco.
Right, it's Europe and Africa.
This week, a massive surge of roughly 50,000 migrants attempted to cross the fences from Morocco into Ceuta in a span of just a few days. The border infrastructure was completely overwhelmed.
It was chaos.
Spain has now deployed the military to the border to restore order, and there are incredibly tragic reports of anywhere from 9 to 41 fatalities, with people drowning in the sea trying to swim around the fence or being crushed in the crowd surge.
It is a devastating humanitarian situation. And geographically, Ceuta sits at the absolute epicenter of the European, and really the global, debate on sovereignty, mass migration, and human rights.
And just like with the AI regulation debate, the political reaction to this border crisis is starkly divided. When you look at the reporting, you see two completely different narratives trying to make sense of the exact same event. Let's look at the right-leaning, security-focused perspective first.
From the right-leaning perspective, the primary focus is squarely on the absolute necessity of strong borders, the rule of law, and national sovereignty.
Okay.
They look at the sheer numbers, 50,000 people surging toward a border fence in 24 hours, and argue that this is the very definition of an unsustainable, irregular migration crisis that threatens the stability of the host nation.
So from this viewpoint, deploying the Spanish military isn't an overreaction, it's the only logical step.
Correct. They view deploying the military as a fundamental, non-negotiable duty of the state to maintain order and protect its territorial integrity. You mentioned the U.S. President, Donald Trump, in the outline of current events.
Right.
This is exactly the type of scenario his administration frequently points to. He recently warned of a Spain-style migrant invasion happening elsewhere, using events like Ceuta as proof that without heavily militarized borders and strict deterrence policies, a nation fundamentally loses control of its own security and social cohesion.
So it is viewed almost exclusively through the lens of national security and maintaining order. What is the left-leaning or humanitarian perspective on the exact same border surge?
The left-leaning perspective focuses heavily on the humanitarian tragedy and the underlying structural drivers of the crisis.
The root causes.
Yes. From this viewpoint, deploying heavily armed military units against unarmed, desperate civilians seeking asylum is a gross violation of international human rights and a failure of human compassion.
Because they're just seeking safety.
They argue that militarizing the border doesn't stop migration, it only forces migrants into deadlier routes, increasing the likelihood of tragedies like the 41 fatalities of people drowning or being crushed, without actually solving the root problem.
Because their argument is that people wouldn't risk their lives or risk their children's lives to climb a razor wire fence if they weren't fleeing something infinitely worse.
Precisely. And this is where we have to engage in systems thinking and connect the dots back to our previous topics. Why are 50,000 people at the border of Ceuta in the first place?
It's all connected.
It is a cascading systemic failure. We just spent time discussing El Nino driving severe, multi-year droughts across vast swaths of Africa. When a region experiences prolonged drought, the local agriculture completely fails.
And when the food stops, everything stops.
When agriculture fails, the local economies, which are heavily agrarian, collapse. Extreme poverty, food insecurity, and the resulting political instability drive people to leave their ancestral homes simply in search of survival.
It's climate-driven migration.
Exactly. That migration eventually hits a geopolitical choke point, like the razor wire border at Ceuta, resulting in a kinetic border crisis. You simply cannot separate the extreme weather anomalies from the economic collapse, or the economic collapse from the border military deployment. It is one interconnected, fragile system.
Wow. Okay, take a deep breath. From 476,000-year-old Zambian builders, to AI autonomous hackers, to global climate migration driving military deployments, we have covered a massive amount of heavy, chaotic ground here on Earth.
That's a lot to take in.
Let's look at the cosmic scale. Unfortunately, it seems we've managed to bring a little bit of our terrestrial chaos up to orbit with us, but the universe still has the power to leave us in absolute awe.
It is the ultimate paradox of humanity. Our technological reach has extended to the stars, but so has our mess.
The space debris situation is getting genuinely out of hand. The data shows that a ton, literally 2,000 pounds of space junk, tumbles unpredictably back through Earth's atmosphere every single week.
That's a huge volume of material.
Dead satellites, rocket boosters, sheer garbage. And right now, there is a drifting SpaceX Falcon 9 upper stage that has been floating around dead for years, and it is currently heading for an accidental, high-speed collision with the far side of the moon.
The SpaceX Lunar collision is actually quite illustrative of our current, somewhat reckless era in orbital expansion. It highlights a very real existential problem for spaceflight known as the Kessler syndrome.
Kessler syndrome. I've heard that term used in sci-fi movies, but what is the actual science behind it?
It is a theoretical scenario first proposed by a NASA scientist named Donald Kessler back in the 1970s.
Oh, NASA.
Yeah.
The National Aeronautics and Space Administration.
Yes. He warned that the density of objects in low Earth orbit could eventually become so high that a single collision between two satellites generates a massive cloud of high-speed debris.
Just a cloud of shrapnel.
Because things in orbit are moving at roughly 17,500 miles per hour, even a tiny fleck of paint hits with the force of a bomb. That initial debris cloud then strikes other satellites, causing a cascading chain reaction of collisions.
Until what?
Until orbit becomes completely saturated with lethal shrapnel, rendering it impassable and too dangerous for human spaceflight or new satellites.
So we could accidentally trap ourselves on Earth behind a cage of our own pulverized garbage.
That is the extreme worst-case scenario, yes. We are currently putting infrastructure up into orbit far faster than we can manage its end-of-life disposal.
That's concerning.
However, the Falcon 9 moon impact specifically has a fascinating silver lining for the scientific community. While it highlights our lack of control over orbital infrastructure, hitting the moon with a massive kinetic impactor actually allows scientists to study the lunar crust in a unique way.
Wait, how does crashing trash into the moon help science?
By observing the resulting crater and analyzing the ejecta plume, the dust and rock thrown up by the impact using lunar orbiters, they can learn about the subsurface mineral composition of the far side of the moon.
Which is hard to study otherwise.
Very hard. It essentially acts as a massive free excavation tool.
So it's accidental science. I
Really?
love that we can extract data from a mistake. And speaking of intentional, brilliant science, we are hitting some incredible milestones in space exploration right now.
We really are.
NASA just announced that their Psyche spacecraft flawlessly executed a Mars gravity assist flyby. It is on its way to study a massive metal asteroid called 16 Psyche.
That's a huge engineering feat.
Meanwhile, down here on Earth, Artemis astronauts are currently at the NBL surface, the Neutral Buoyancy Laboratory pool in Houston, testing out the next-generation moon suits underwater to simulate the 16th gravity of the lunar surface.
Right.
But I was looking at the dates in the research, and I noticed this incredible, somewhat tragic juxtaposition. August 1st, 1968 was the exact day that NASA officially ended production of the Saturn V moon rocket due to budget cuts.
That is a profound historical echo. It perfectly captures the cyclical nature of our space program.
Right. In 1968, we cut the funding for the greatest, most powerful rocket humanity had ever built, right before Neil Armstrong even walked on the moon for the first time.
It was a very abrupt halt.
And today, decades later, we are back to practicing in underwater pools, trying to painstakingly rebuild the capacity and the institutional knowledge to return there. It feels like we took a massive 50-year detour.
It is a stark testament to how heavily space exploration relies not just on engineering, but on political will and sustained federal funding.
Yeah, you need the money.
The Saturn V cancellation was a jarring reminder that scientific ambition is always tethered to the harsh realities of a budget cycle. But the Psyche mission you mentioned represents the flip side of that coin. It shows how we have learned to do incredibly complex things with fewer resources. A gravity assist maneuver, for example, is brilliant orbital mechanics.
How does that actually work? Because it sounds like you were just getting pulled in by gravity, which should make you crash.
It's all about the angle of approach. The spacecraft intentionally flies close to Mars, trailing slightly behind the planet in its orbit. As it falls into Mars' gravity well, it steals a minuscule fraction of the planet's orbital momentum. It uses that gravitational pull to slingshot itself forward, gaining massive amounts of velocity without burning precious fuel.
And what happens to Mars?
Mars slows down by an imperceptible fraction of a millimeter per century, and the spacecraft gets hurled toward the outer solar system. It is elegant, efficient engineering.
Stealing momentum from a planet. It's beautiful. And the engineering breakthroughs aren't just happening in the vacuum of orbit, they're happening at the absolute smallest scales imaginable.
The material science is advancing rapidly.
The physics and materials science research right now is reading like pure magic. Scientists have just synthesized a new cobalt aluminum alloy that is up to 10 times stronger than traditional steel, but somehow it retains incredible flexibility.
That's a game changer for construction.
We have ultra-fast X-ray pulses using an instrument called an XFEL, which stands for X-ray free electron laser, that have literally captured chemistry unfolding atom by atom in femtoseconds.
Mind-blowing.
And then there is this mind-bending concept of electron lighthouses, where physicists are using precise laser light to steer electrons through semiconductors without using a traditional battery.
I know it sounds like a barrage of science fiction buzzwords, but the unifying theme across all these breakthroughs is profound. Humanity is gaining the ability to manipulate reality at the foundational, atomic, and photonic levels.
Okay, let's unpack the X-ray laser first. What does it actually mean to capture chemistry in a femtosecond?
To understand the scale, a femtosecond is 1/millionth of 1/billionth of a second.
I can't even picture that.
It is a sliver of time so incomprehensibly small that there are more femtoseconds in 1 second than there are seconds in 31 million years.
Whoa.
Exactly. Now, for decades, chemists knew the starting ingredients of a chemical reaction, and they knew the final product. But the actual physical moment of transformation, the instant a chemical bond breaks and another reforms, was a complete black box.
It's just too fast.
It happened way too fast to observe. The XFEL changes that. It works like an ultra-high-speed, incredibly intense strobe light. It fires X-ray pulses so fast and so bright that they can take stop-motion snapshots of vibrating molecules, and we can now stitch those snapshots together into a movie.
So you can watch a chemical reaction happen.
Well, we can literally watch atoms reorganize themselves in real time.
Yeah, it is staggering.
Yeah.
But for the listener wondering how this impacts their day-to-day life, why does atomic-level photography matter?
Because if you can see exactly how a reaction happens, you can engineer it to be perfectly efficient. You can design custom catalysts.
Oh, to make better products.
This directly paves the way for designing next-generation zero-emission fuels. For instance, there are new processes being developed right now to turn global plastic waste directly into hydrogen fuel, and perfecting that relies on understanding these exact atomic-level catalytic reactions.
That would be huge for the climate.
Exactly. Similarly, the electron lighthouse concept you mentioned, using light to conduct and steer electrons instead of relying on bulky, heat-generating electrical batteries, could lead to quantum computing components that are microscopically small and operate with near-zero energy loss. We are learning to play with the fundamental building blocks of the universe.
And if you want to talk about playing with the fundamental extremes of the universe, we have to talk about black holes. The outer limits of our observation are yielding some wild stuff this week.
Astronomy is having a golden age right now.
Astronomers just found asteroid 44 Nysa, which is this bizarre three-headed asteroid that has its own tiny moon orbiting it.
Yes.
NASA's Swift Observatory caught a wandering supermassive black hole, completely devouring a star 30,000 light-years away in a violent tidal disruption event.
Just tearing it apart.
And there is a new, highly debated theory that tiny primordial black holes relics left over from the Big Bang, some no bigger than an atom but weighing as much as a mountain, might be skimming through dead white dwarf stars and causing them to ignite and explode into type ES supernovas.
It's a fascinating hypothesis.
But the most mind-bending thing in this entire stack of research is from a theoretical physicist at Oxford. He suggests that advanced civilizations, or maybe humanity in the distant future, could theoretically harness spinning black holes, known as Kerr black holes, to harvest limitless energy, process quantum data, or use gravitational lensing to eavesdrop on aliens.
It's a wild concept.
I brought this up in the intro, but I need to make sure I'm grasping this. We want to use a black hole as a cosmic magnifying glass to spy on ET.
It sounds utterly absurd when you say it out loud, but the underlying mathematics and physics are completely sound. It is a beautiful theoretical reminder of what extreme gravity can enable.
Okay, walk me through it.
So let's break down the Kerr black hole, because it is different from the simple black holes we usually imagine. Unlike a static black hole, a Kerr black hole is spinning at an appreciable fraction of the speed of light.
Okay, so it's rotating.
And because it has such immense mass, as it spins, it literally drags the fabric of space and time around with it. This phenomenon is called frame dragging.
Think of it like a spoon spinning in the center of a really thick bowl of honey. The honey, right next to the spoon, gets dragged around in a circle.
That is the perfect analogy. This frame dragging creates a region just outside the black hole's event horizon called the ergosphere.
The ergosphere.
Inside the ergosphere, space-time is being dragged around faster than the speed of light. You physically cannot stand still in the ergosphere. You must move in the direction of the spin.
That is crazy.
Now, back in 1969, the physicist Roger Penrose proposed a theory now known as the Penrose process, suggesting that you could shoot a mass, like a garbage pod or a specialized projectile, into the ergosphere, split it in two, let one piece fall past the event horizon into the black hole, and the other piece would be ejected out.
And what does that do?
Because of the rotational energy of the space-time it was riding, the escaping piece would fly out with vastly more kinetic energy than it went in with.
It would literally steal rotational energy from the black hole.
Precisely. It is the ultimate cosmic power plant. Alternatively, you could use the Blandford-Znajek mechanism, which theorizes using the intense magnetic fields twisting around the black hole to siphon immense amounts of electromagnetic energy.
Okay, so that covers harvesting energy. But what about the eavesdropping? How does a black hole act as a telescope?
That relies on gravitational lensing, which was predicted by Einstein's theory of general relativity.
Right.
Because a black hole's gravity is so intense, it actually warps the path of light passing near it. It bends the light rays. If you position a detector like a highly advanced radio telescope at the perfect focal point opposite a distant star system, the black hole acts as a galaxy-sized magnifying lens.
That's genius.
It focuses and amplifies faint electromagnetic signals from deep space. If an alien civilization is broadcasting radio waves or laser communications on the other side of the galaxy, the black hole could theoretically magnify that signal enough for us to detect it.
That is just, it is staggering to think about. It shows that no matter how chaotic Earth gets with climate crises and political borders, the universe holds infinite untapped potential. The physics of reality are so much stranger and more beautiful than we experience day to day.
It does. It provides a sense of scale that I find deeply necessary when the daily news gets overwhelming. We are a tiny species on a fragile rock, but our capacity to understand these cosmic mechanics is boundless.
It really is. And we have covered a staggering amount of ground today. We started by looking at 476,000-year-old wooden structures in Zambia, redefining what our ancient pre-sapiens ancestors were capable of building.
A lot of history there.
We explored the ethical minefield of using beta blockers to edit the emotional weight of human traumatic memories, and the dark irony of AI acting as our best friend, while simultaneously, autonomously hacking networks during cybersecurity red teaming tests.
The dual nature of tech.
Exactly. We mapped the brutal reality of the climate crucible, from El Nino driving deadly heat waves in the UK and wildfires across Europe, to the deeply interconnected humanitarian border crisis in Ceuta. And finally, we looked out into the cosmos, marveling at the capability to watch chemistry unfold atom by atom in femtoseconds, and the jaw-dropping theoretical physics of using spinning Kerr black holes as galactic power routers and alien listening posts.
It is an immense amount of data to process. But if there is one core thought I want you, the listener, to mull over as we wrap up today's journey, it is this. If we are a species capable of peering into the microscopic neurochemistry of the brain to selectively edit out traumatic memories, and if we are mathematically capable of calculating how to extract limitless energy from the ergosphere of a spinning black hole,
Right.
Are we not also capable of cleaning up the messes we leave behind, both in the polluted mangroves of our oceans and the tumbling debris in our orbital pathways? Our technological reach is practically infinite, but it seems our collective wisdom is still playing a dangerous game of catch-up.
That is an incredibly powerful question to end on. It brings us right back to the dual nature of humanity we've been discussing all hour. Every piece of news, every archaeological breakthrough, every climate crisis, every AI evolution we discussed today is just another data point mapping who we are.
It's all connected.
The world is going to keep shifting, but it is ultimately up to us to decide what we do with this godlike capability we are building. Thank you so much for joining us on this deep dive. Keep questioning, keep exploring, and we'll see you on the next deep dive.
Enjoying Artificially Informed.
Hit subscribe and share it with a friend.
From the left, the right, and straight from the algorithm.
Thank you.
Welcome to the debate. This year, the global tech industry dumped roughly 140,000 workers.
Yeah, it's a staggering number.
Right? But in that exact same window of time, a staggering $1 trillion in capital was poured directly into AI infrastructure. So we are witnessing what is arguably the most aggressive, rapid reallocation of global capital in human history.
And it's not just happening in Silicon Valley either.
No, absolutely not. From the volatile energy corridors of the Persian Gulf to the United States actively competing for a $12.5 billion airport project in Ethiopia, just to edge out China, by the way, the entire global architecture is undergoing this profound planetary reordering.
And I would add, it's a reordering that is happening at breakneck speed. It's leaving an enormous amount of collateral damage in its wake.
Which brings us directly to the central question we are debating today. Are these current technological and economic shifts, driven by market forces and diplomatic realignments, are they successfully forging a more resilient, multipolar global architecture? Or are they driving a dangerous fragmentation, one that basically prioritizes unchecked corporate profiteering over human and environmental stability?
Right, that's the core tension.
Exactly. And today's discussion draws on a wide array of recent global reporting. We're looking at market trends, international relations, technological breakthroughs. And I will be taking the position that these aggressive capital shifts are exactly what resilience looks like. They are necessary, market-driven adaptations that are building a robust defense against systemic economic stagnation.
And my position is that this so-called resilience is really just a mirage. What we are actually experiencing is a fundamentally destabilizing fragmentation. It's a system characterized by massive corporate extraction and the deliberate alienation of the global south, which, ultimately sacrifices long-term human security just to maintain short-term power.
Well, if we look at the macroeconomic data, for instance, the recent Trends Journal report detailing that near $1 trillion investment in AI, we have to recognize that this isn't some speculative bubble.
You don't think so?
No, it is a necessary structural pivot. Western productivity requires it for strategic autonomy. Yes, there are extreme pressures right now. We have severe volatility in the Persian Gulf. We have the ongoing war in Ukraine straining global supply chains. But the global market is efficiently pricing in those risks.
Efficiently pricing them in?
Yes, efficiently adapting. When you see the U.S. proactively bidding on Ethiopia's Bishoftu International Airport to counter China's Belt and Road dominance, you are looking at a dynamic system. It's adapting in real time to secure supply chains and maintain integration.
But look at the actual mechanics of that adaptation, though. The macroeconomic view you're presenting completely ignores the human and environmental costs, and those costs are the actual foundation of this transition.
Well, let's unpack that.
Let's go back to that glaring paradox in the tech sector you brought up. 140,000 workers are deemed disposable, while $1 trillion flows into silicon and data centers. That is a massive concentration of capital. And if we look at the physical world, it's the same story.
How so?
Well, the BBC and Climate Change News just reported that Shell effectively doubled its profits directly off the back of the Iran war and disruptions in the Strait of Hormuz.
Geopolitical friction drives energy prices, yeah.
Right, but at the exact same time, internal documents show they are trying to offload the cleanup costs of a 375 square kilometer mangrove oil spill in the Niger Delta onto local Nigerian firms. This is not resilience. This is an extractive playbook. You socialize the costs, you privatize the gains, and you leave the developing world to clean up the mess.
Okay, let's actually dig into the mechanics of that first point you made, though. This massive migration of capital from human labor to AI infrastructure.
Sure.
The 140,000 lost jobs is a painful statistic, absolutely. I'm not denying that. But structural transitions require capital deepening. You simply cannot build the infrastructure of the next century without concentrating capital first.
But what kind of infrastructure are we actually deploying? We are building systems that centralize power and introduce critical vulnerabilities at a speed we just cannot control.
I think the market is controlling it better than you suggest.
I disagree. It isn't just about job shifting, it is about the fundamental safety of the architecture. The BBC covered a recent cybersecurity report revealing that Anthropic's Claude AI actually hacked 3 external firms during cyber tests.
Wait, but to be fair, those were controlled red team exercises.
Yes, they were.
The AI was placed in an environment specifically designed to test its outer boundaries and, find vulnerabilities.
Yes, they were controlled exercises. But if you understand how a capture the flag scenario works, the implications are terrifying. The AI is given a broad goal like, find the hidden data file in this network.
Right.
It isn't given step-by-step instructions. In these tests, the AI agents independently mapped the target networks. They identified zero-day vulnerabilities. They wrote the exploitation scripts themselves, and they breached the systems.
All autonomously?
Completely autonomously. It proves that the rush for market dominance is entirely outpacing safety. We have $1 trillion of capital demanding a return on investment, so we are rushing autonomous agents to market that are capable of national security-level intrusions. We're replacing a human workforce with automated systems that we barely understand.
Okay, I see why you'd say that, but let me give you a different perspective. If you're listening to this and wondering if we're just building some extractive, dangerous machine, I think we have to look at the global footprint of this tech transition.
Which is highly concentrated.
Not entirely. If AI capital was purely centralizing power in the West, we wouldn't be seeing this massive, unprecedented boom in capability centers across the developing world.
Well,
Let me finish this thought. Sanjeev Sanyal, who is a top economic aide to India's prime minister, recently made exactly this point. He argued that labor markets have to adapt to AI rather than legislating to protect obsolete roles. India is right now successfully hosting major global capability centers for tech giants like Microsoft, Google, and Meta.
right for cheap labor.
No, they aren't just doing back-office support anymore. They're contributing to the engineering of foundational AI models. Think about it like the containerization of global shipping in the 1950s.
Containerization?
Yeah. When shipping containers were introduced, it was incredibly disruptive. It eliminated the need for hundreds of thousands of dock workers around the world who used to manually load cargo. It felt like a massive loss of labor.
It was a massive loss for those workers.
In the short term, yes. But by standardizing global logistics, containerization mathematically multiplied the volume of global trade. It integrated developing nations into the global market and ultimately created millions of new, higher-value jobs. AI is just the containerization of cognitive labor. It's a productivity multiplier. The market is signaling a shift from routine cognitive tasks to complex problem-solving, and developing nations like India are catching that wave.
You know, the containerization analogy actually proves my point perfectly.
How so?
Yes, it multiplied global trade, but it also hyper-concentrated wealth in the hands of the massive logistics conglomerates who owned the ships and the ports. The efficiency gains accrued almost entirely to the owners of the capital.
Well, they took the initial risk.
Sure, but when a tech giant today lays off 10,000 workers to buy specialized AI chips, it isn't automatically creating an equal number of high-paying jobs in Latin America or South Asia. It is automating processes purely to protect corporate margins. The global labor force is left to absorb the shock of displacement, while the market signals operate entirely without moral or planetary guardrails.
That's a bit cynical.
It's the reality. And frankly, that same underlying logic, deploying capital where it yields the highest return, regardless of the local fallout, isn't just happening in the cloud. We are seeing the exact same playbook in the physical energy markets right now.
So you're drawing a parallel to the windfall profits in the fossil fuel sector?
Precisely. We are hoarding tech capital exactly like we are hoarding energy wealth. Like I mentioned, we see Shell doubling its profits primarily because of geopolitical tensions in the Persian Gulf. They are profiting off the friction, meanwhile the planet is literally on fire.
The climate impacts are real, yes.
The UN Economic Commission for Europe, UNECE, just released data showing 434,000 hectares burned across Europe this year alone. And if we look back just to 2021, wildfires released 1.8 billion tons of CO2. Do you know how that mechanism works?
The feedback loop.
Exactly. It creates a devastating locked-in feedback loop. Hotter conditions fuel larger fires, the fires release massive amounts of greenhouse gases, which further heat the atmosphere, ensuring next year's fires are even worse.
Which is exactly why we are seeing such aggressive international climate negotiations right now.
But the negotiations aren't stopping the extraction. This is why there is a massive push, which was documented by Climate Change News, for a strict 20% windfall tax on the world's top 100 oil and gas companies.
Right, the windfall tax debate.
That single tax could generate $1 trillion to fund climate resilience. Instead, our current global architecture rewards companies for geopolitical instability, allows them to pocket the windfall, and lets them abandon their environmental liabilities.
Ah, so you're bringing us back to the Niger Delta and Shell's divestment in Nigeria.
Yes, because it is the perfect physical manifestation of this architecture. Internal documents from as far back as 2013 show Shell executives asking if the company has the appetite to take on the open-ended problem of a 375 square kilometer mangrove oil spill. A spill they are largely responsible for, I might add.
Well, there are legal complexities there regarding pipeline sabotage, but go on.
Instead of spending the billions required to actually remediate the soil and water, they fast-tracked the sale of their onshore assets to local Nigerian firms that simply do not have the capital to execute a cleanup of that magnitude. They are prioritizing shareholder profit over planetary stability.
Hold on. I really have to push back on that. Because you are analyzing global energy dynamics through a strictly Western environmentalist lens.
Wanting clean water in Nigeria is a Western lens?
No, but assuming that Shell's departure is a pure evasion of responsibility is. From a market perspective, it is a standard portfolio shift. Shell is moving its capital to offshore assets, which they argue simplifies their operational footprint in a region that has been severely plagued by pipeline sabotage and oil theft.
A portfolio shift that conveniently leaves billions of dollars in cleanup costs behind for a developing nation to handle.
But look at the broader mechanics of how the Global South actually views energy, development, and this entire transition.
Okay.
If rapidly moving away from fossil fuels was universally stabilizing, why are developing giants like India and China leading the resistance against those rapid phaseouts?
Well,
look at the recent Belém mission to 1.5 at COP30 in Brazil. The LMDC bloc, that's the like-minded developing countries which acts as a unified negotiating front for China, India, and several Arab states. They actively pushed back against Western dictates to rapidly phase out coal, oil, and gas.
right.
Why? Because the mathematical reality is that their economic development and the alleviation of poverty for billions of their citizens still heavily relies on the high energy density of those fuels. So aren't you effectively demanding a transition timeline that the Global South itself fundamentally rejects?
I see what you're saying, but that assumes the Global South is rejecting the transition itself, which they aren't.
What are they rejecting then?
What the LMDC bloc at COP30 is rejecting is Western hypocrisy. Walk through the actual mechanics of what those nations are saying at the negotiating table. They are saying to the West, you built your vast wealth and your resilient infrastructure by burning fossil fuels for 2 straight centuries. Now that we are trying to industrialize, you want us to halt our development, but you completely refuse to provide the necessary climate finance to fund our green transition.
Okay, that's fair.
They are resisting a global architecture where rich countries dictate energy choices without paying what they owe in historical climate debt.
That is a completely fair distinction. They want the focus on climate finance and technological transfer rather than top-down energy dictates. But honestly, I think that friction illustrates my core point perfectly.
How does friction prove resilience?
Because the market and the current diplomatic architecture are actually functioning to balance these highly complex, competing needs. The West cannot simply dictate terms anymore. The resistance from the LMDC bloc is a feature, not a bug, of a maturing multipolar world. It proves that developing nations have genuine agency and the leverage to force a more equitable transition.
But that agency is increasingly being used to actively fragment the global order, precisely because the Western-led system has proven so extractive and unreliable. The Global South isn't just negotiating for better terms within the system anymore, they are physically building bypasses around it.
I assume you're pointing to the diplomatic realignments and the de-dollarization efforts we're seeing in global finance.
Exactly. The West is losing its economic grip because it weaponized the architecture. Look at the situation with Bangladesh. RT recently reported on the massive $13 billion root-pour nuclear power plant that Russia is building for Bangladesh.
Right. This is the payment issue.
Because the United States controls the SWIFT messaging system and has placed heavy sanctions on Russian banks, DACA physically cannot clear dollar transactions to pay Moscow. So what are they doing? Moscow and DACA are having to establish complex bilateral payment infrastructures using the Indian rupee.
But let's explain how that actually works for our listeners. It's not just a simple wire transfer.
No, it is incredibly complicated. They have to set up specialized Nostro and Vostro accounts with Indian banks acting as intermediaries. They're essentially mapping out an entirely parallel financial plumbing system from scratch just to service this debt and keep the lights on.
Right.
This isn't just a clever accounting trick. This is the physical dismantling of U.S. financial hegemony. When countries realize the dollar can be weaponized against them, they start building alternative highways.
You know, I look at the mechanics of that exact same situation and see a completely different outcome.
Really?
Yes, the fact that Bangladesh and Russia are forced to find a highly inefficient clearing mechanism using the Indian rupee doesn't mean the global system is collapsing. It means the system is incredibly resilient. Sanctions were placed on Russia for a blatant violation of international law in Ukraine.
True.
The financial system worked. It isolated the aggressor.
The fact that two sovereign nations have to build a convoluted, expensive currency workaround from scratch just to bypass SWIFT, that actually highlights the immense, enduring gravity of the established financial architecture. It proves how hard it is to actually fragment the system.
But the sentiment driving that workaround is spreading far beyond complex banking logistics. I mean, it is a fundamental shift in diplomatic trust. Look at the recent African youth survey conducted by the Ishakovitz Family Foundation.
The one across 16 nations, right?
Yes, they surveyed nearly 5,000 young people across 16 different African nations. 26% of young Africans explicitly stated they see an upside to the United States cutting USAID funding to their countries.
Because they believe the removal of foreign aid will force domestic self-reliance.
Yes, because they understand the mechanics of how that aid functions in reality. It often comes with heavy conditionality, and it can actively stifle local agricultural and industrial markets. They view the cuts as a necessary catalyst to end a toxic reliance on Western donors.
It's a push for sovereignty.
Exactly. When more than a quarter of the youth on an entire continent view the removal of your humanitarian aid as a positive step for their own sovereignty, your diplomatic architecture is failing. And while the humanitarian architecture crumbles, the quote-unquote security architecture the West exports is literally bleeding into global criminality.
Okay, you're referring to the weapons leakage from the Ukraine conflict here.
I am. Senior Italian prosecutors recently warned the Anti-Mafia Commission that organized crime syndicates, specifically Cosa Nostra, are actively trying to buy up portions of the estimated 800,000 weapons that have gone missing from Ukraine.
Wow. 800,000.
We are talking about the complete breakdown of end-user certificates and military logistics. Western military exports, funded by taxpayers and meant to stabilize a democracy, are now flooding the European black market to arm the mafia. I mean, that is the literal definition of dangerous fragmentation. The center is not holding.
All right, let's address the reality of arms transfers first. In any major chaotic conflict, especially when moving at the speed of the war in Ukraine, there is going to be a degree of logistical leakage. The fog of war makes perfect inventory control basically impossible.
That's a mild way of putting it.
It is a tragic reality of war. But the fact that Europol and Italian prosecutors are actively tracking this, identifying the smuggling routes and testifying before parliamentary commissions, that actually shows that the institutional safeguards are working. The rule of law is actively adapting to mitigate that spillover.
Tracking 800,000 missing weapons after they vanished into the hands of criminal syndicates is not a success story of institutional safeguards. It's a post-mortem of a failed policy. It is reacting to fragmentation, not preventing it.
But if we zoom out to the broader diplomatic realignment you mentioned earlier, this idea that the world is fracturing into isolated blocks, I just don't see the data supporting a collapse.
What do you see then?
I see a maturing multipolar world where nations are learning to balance competing interests. Take Turkey, for example, as the ultimate archetype of this new era. President Erdogan maintains deep, ongoing ties with Russia. He has explicitly refused to fully join the West's economic sanctions against Moscow, and he continues to negotiate massive energy and transport deals with Putin.
Which severely undermines the united front against Russian aggression.
But simultaneously, Turkey remains firmly entrenched in NATO. They control the Bosporus. They are maintaining strategic autonomy. They are proving that in this new architecture, a nation can have a fiercely independent foreign policy, refuse a simplistic binary choice between East and West, and still coexist within established global security frameworks.
I don't buy that.
It isn't a collapse into anarchy. It's diplomatic sophistication. It's a world where countries act in their rational self-interest without blowing up the underlying system.
It is diplomatic opportunism, not sophistication. Erdogan's stance isn't stabilizing the global order. It's purely transactional. When nations start treating foundational security alliances like an a la carte buffet, taking the ironclad security guarantees of NATO while simultaneously funding the war machine of NATO's primary adversary through billion-dollar energy purchases, that fundamentally rots the architecture from the inside out.
You see it as rotting? I see it as flexibility.
It creates a global environment where every single crisis is viewed merely as leverage for a bilateral deal. That isn't a resilient multipolar world. That is a fractured global order held together by short-term opportunism, where the highest bidder wins, completely regardless of the human, environmental, or institutional cost.
Well, I think we have clearly mapped the fault lines of this debate, and we've covered immense ground today. If we step back and summarize the mechanics of what we've discussed, my position remains that the transition we are living through is undoubtedly turbulent. We are seeing painful tech layoffs, we are seeing energy price shocks, and we are seeing intense friction in global finance.
Very intense.
But the aggressive reallocation of capital, whether that is $1 trillion moving into AI infrastructure to serve as a new productivity multiplier, or the proactive, competitive diplomacy we see with infrastructure investments in Africa, it all demonstrates a global system that is successfully adapting. It is forging a more flexible, multipolar defense against systemic shocks.
And my summary is that the mechanisms we've explored today reveal a world that is dangerously fracturing under the weight of corporate greed.
Right.
We have an architecture where tech giants rush hacking-capable AI to market while shedding 140,000 human workers. We have energy majors doubling their profits off geopolitical warfare while leveraging legal loopholes to offload environmental disasters like the Niger Delta onto developing nations. And we have parallel financial systems being built specifically to evade a Western security apparatus that is currently bleeding arms into the Italian mafia.
It's a stark picture.
A global architecture that consistently socializes these massive risks onto ordinary citizens while privatizing the trillion-dollar windfall profits is fundamentally unsustainable. It requires urgent, systemic governance reform, not just blind faith that the market will eventually balance itself out.
Yet despite our profound disagreements on the morality and the ultimate destination of these massive shifts, I believe we do arrive at a crucial point of convergence today.
I agree.
We both acknowledge that the world has irreversibly moved away from a unipolar, US-centric model. We are now operating in a highly complex planetary ecosystem. It is a world where nations in the global south are actively asserting their agency to demand climate finance, where alternate financial bridges are being built in real time, and where artificial intelligence is fundamentally rewriting the bedrock rules of labor and capital.
Absolutely. The unipolar moment is definitively dead. The question that remains is simply what kind of architecture will rise from its ashes and, who will ultimately pay the price for its construction.
Exactly. Examining these overlapping market and diplomatic trends from multiple perspectives and digging into the actual mechanics of how our world is changing is exactly why we have this show. There is so much more to explore in this evolving global landscape. We will leave it to you, the listener, to form your own conclusion on where the balance of global stability truly lies. But as you watch these trillion-dollar shifts in capital, technology, and diplomacy unfold in the coming months, ask yourself, are the disruptions we are living through the breaking apart of our world, or are they the necessary, violent friction of an entirely new one being formed?
Thanks for listening.
Thank you for joining us on the debate.
That's it for today's Artificially Informed.
Nope. Thanks for spending your time with us.
Yeah.
Stay sharp, stay curious. See you next time.